Welcome to a new test and teardown video. This time we're looking at a Grundig CB radio test station. It's called messplatz CB6. And you can find this on Radio Museum, and that means you can find a lot of additional information, including it should be from 1978 to 1979. And yes, of course, they talk about it's a 40-channel CB radio system. So you dial in the channel you want to test, and then it can transmit and receive, yes, of course, from 26.965 to 27.405, and that is channel 40. So far, so good. It should also contain a frequency counter. That one seems a little bit dodgy. I see only slight blinks and stuff on that one. It can generate IF 10.7 megahertz and 455. So that is an external signal of 390 hertz, and I put this for 400 hertz. I think the sweep frequency of the CRT is kind of locked to its internal, see, to that generator here. So if I change this generator to another frequency, then my scope just changes behavior. So there's an auto trick on its own signal generator, which is quite nice. So I believe the way that it works, it's generating this frequency. It comes out of the output, and then you can put it through the system that you're testing, and then your input here. I'm trying to speak German because I'm reading this Eingang. So yes, of course. So you read this input. I'm sorry about that. I'll try to do the English version, but it's a little bit difficult because the first line is in German. So that is how it works, right? And this way you get your picture, and also see the frequency counter here is responding, but there's definitely some digits, as you can see here, that's not working. I will of course have to play with that. Funny is 1.5 watt, 15 watts. So I thought that was the RF transmitter power, but this has something to do with the audio power range. Isn't that funny? So you can load it in different ohms, and then this power meter will read the correct amplitude or the power, right? That's interesting. I haven't figured out yet what calibrate scope is doing. Not a lot. And how do you change this from being receiver or transmitter mode? I haven't yet figured that out. Maybe I'm just, maybe this is automatic, or maybe I have to click some stuff here, right? I don't know, maybe I'm too stupid to figure this out yet. Maybe I should just go and find my old CB radio. And then, okay. So this is modulation. And then you put it into RF level, and then you dial the RF level. Fantastic. And then you have, of course, RF attenuator. Cool. Well, there's a nice and beautiful picture on the CRT. So, so far, so good. Oh, I think I figured this out. So this is the internal. That means the frequency counter is connected to the RF input-output here, right? So, right now I am in external, and that is that input. And if you see here, it's 1 point, and then this kind of stuff, and that is megahertz. My input here is at the moment 1 megahertz. So something tells me that the base front end of this counter is actually working, but we got some multiplexer problems. Because let's see, This is 1.1, 1.2, 1.3. Okay, so the frequency counter works, but what if I go to 2 megahertz? Yeah, 2.2. Yeah, that is 2.2. So we also got a multiplexer problem. That is something I should easily be able to repair, by the way. See, I was able to go and find my good old CB radio. And it appears to be working. I don't know, it's 30 years ago or something like that. I put this in a box somewhere and then I was able to find it. What kind of funny luck is that? And now I'm here on the call channel 4, and let's see if this thing works. So this is the squelch and volume. Look at that. So if I squelch out, I can hear the noise on the channel, and you see the scope is here. So what I did is I connected the audio input to the speaker output in parallel with the speaker. This way we can see, or we can hear what is going on at the same time. Otherwise, it's not that interesting to see what we're doing here. So let's try and crank up the HF level. So this is now in the weakest range, and then I dial it up. Look at that. And then we can test the sensitivity by adjusting the level. And if we give it a little bit more, we don't hear so much noise, then I should be able to give it, see, a little bit of audio. So this is, of course, the modulation, and I can, as you can see here on the scope, overdrive. Let's hold a hand here. So yeah, so this is how it works. We can definitely test this radio and see that it works. And it's not receiving any other channels. We can even hear how it goes in and out of squelch, and you can see there's a big blob. You can even hear it. This is one of the things that really always it annoyed me when I was a kid using this radio. This click, clack, click. Can you hear it? This is really not necessary. Okay, so I believe this CB radio test stand here is working, except for the frequency counter. So let's try and see something funny. I'm now still on channel 4, and if I hit the transmit button on the microphone, see? Hello. It goes into speaker mode. And you see it here on the, see the audio when I hammer the microphone, and it tests the frequency, and you can also test the transmit power. And for some reason you can also see the, if you're running on AM or FM, you can see this is of course the RF that you're making, you're transmitting, and I can also see that my transmit power is a little bit over legal limit. In case this one is correct, 15 watts for full range, then it is probably a lot of watts too many, if I'm not mistaken, 6-7 watts. So yes, that is I think how it is with these radios. They're not super accurate when it comes to transmit power, but this one is just a little bit over, so that's fantastic. So before we go open it, I just wanted to show you the rear side. I think it's super easy to open. It's probably just those 4 screws and those, and then we're done. There's a nice little name label, and it says 40 watts. I think I measure only 25, so that's probably a little bit over the top. And this one was definitely from the good old days when we had 220 only. I also found a little bit of a adjustments for the CRT. So this is trace rotation. Wow, nice focus and intensity. It's really beautiful inside. It looks very much Japanese in the design. So that will be the CRT board. I think this also contain a sweep generator, and it's probably also a mixer. So it's mixing down to 455 kilohertz for the super slow deflection system here. So that's probably what it's doing. It's of course always running in slow speed. This is not a 27 megahertz capable video system. I believe this is a normal CRT. So I don't think it should be a static deflection. But the fun thing is, look at that. I believe this is the anode connection, and there is no connector in that one. So I think that is a little bit funny. And it of course works without this connection. The two yellow wires, that will be trace rotation, and they go to two little transistors and a potentiometer here. So classic trace rotation, high voltage transformer, and some diodes down here for high voltage. There's even a little flyback circuit and a feedback system. It says here high voltage adjust on this trimmer down here. So all this quite classic, nothing fancy special. And a little power supply with 4 different voltages. All the voltages, they're written all over the place, and nice test points, super easy to access. I think those coax cables here goes to, this is probably the RX-TX switch, and then this will be an attenuator power coupler or something like that. That looks like a power resistor that's supposed to be here on the back, because when you transmit you go straight into this resistor, and then there's of course a coupler that goes to this resistor from the attenuator system, so it's just automatic change over from RX to TX. That will be this long switch here. That is the AM/FM modulation switch, and there's of course a lot of different circuits here that will handle the different modulation styles. And look at that nice switch and the flex PCB here. Ain't that nice? So that will be the 7 segments for the channel switch, and that channel switch is this special BCD decimal 7 segment kind of coding system that goes to that PLL chip in that format, and that is quite fascinating. This is the way it's done. And then down here will be a PLL chip somewhere. I found the transformer down here, and there isn't anything in here except for the deflection system for the CRT. So there's probably some sort of coils and stuff down there. I don't have access to that right now. Maybe we'll figure that out later. The bottom side of the unit is of course completely shielded. So we got 3 interesting magic boxes. Can't wait to look in those. This is of course the frequency counter readout. So I believe that will be the frequency counter. As you can see here, the display goes to this little, that is difficult to show. Where is it? Here is the connector. So that connector goes into this box, and that looks just like what it can do for the frequency counter. I have no clue what's in that fancy box here, and that's probably the whole transmit receive frequency generator. I wouldn't be surprised if we find an old 40 channel CB radio in here, more or less in in its own standard PCB. I mean, that will be how I would have done this, really, because it came super cheap in the 80s. How about we just look inside the boxes? No. This is this is one of those babushka presents when there's another present inside the first present. So okay, we have to go in again. I removed all the covers, and now we can see what we're doing here. Look at that. Input RF relay, and that one here goes to the input connector, right? And I believe what we got here, that will be some sort of input level detection, and then it switches over. So the input goes to a load instead of going to the attenuator, obviously, right? And then when it goes to the load, it also detects that, oh, now we are in transmit mode, because this is auto for this model. The previous model had a switch in the front, so you manually had to do that. But this one is, of course, auto detect. And then it goes into load and power measurement instead of signal generator mode. Also, a lot of other stuff happens when we do that. The scope, for example, goes to RF mode actually. So I was a little bit wrong about the CRT. I think we'll go and play a little bit with the CRT. But it is a static deflection, and it is actually measuring 27 megahertz directly on the plates. They made a really nice, funny injection system for that. So here I believe we got the two crystals for the generator and detectors, and this one is a 10.24 megahertz. This one is a standard crystal, also to mix down from 10.7 to 455 kilohertz. And then here is a 36 megahertz crystal for the first IF. So I think this is actually a triple conversion receiver chain here, because that will be the 36, the 10.2, and then the 455 is over here. So this is the AM and FM receiver. And yes, so yeah, we got 3 IF. I think this is part of the transmitter or the signal generator. And we got the frequency counter here. Frequency counter is a little bit funny, because it also consists of a down converter. I think that is what it is on the frequency counter. And then we have some pre-scalers, and the counter unit itself is a TC 5032. That is an all-in-one frequency counter chip for multiplexed displays. What you can do is, you can of course read it out in any mode you want, but the BCD output goes to a BCD to 7-segment decoder, that one, and maybe there is an output here that is defect or broken, because we got the same segments broken in all the different 7 segments. Remember, we also got one of them that is not turned on as well. So I believe that is the multiplex driver here, where one of the transistors could be defect. So that is what I want to play with now, and then we'll see if I can figure that out. There's a little funny thing about this design, by the way. Look at that. All the modules, they're completely loose. Once the lid is removed, and those 2 screws, that's the only thing that holds each of the modules down to that base plate. Isn't that a little bit of a funny design? Yeah, the attenuator is, of course, completely shielded and all that. It's not super difficult to make attenuators for 27 megahertz, so I believe it's just a few sections with resistors and stuff like that. It's not supposed to be that difficult to make at so low frequencies. So I've been investigating a little bit here on the frequency counter. That will be the PNP transistors that select each of the 7-segment common, and that will be the resistors for the 7 segments and the 7-segment BCD decoder. I've been measuring all the tracks from the connector to the decoder, including the resistors. All that is okay. And all the PNP transistors, they can of course now be tested, because they're not connected to the displays. And all those are also okay, at least when you diode beep them. So I think there is a chance that this 7 segment that is not working has a shorted diode. So when you select that digit, it's just not going to light up, right? And yeah, that is a possibility. That is what is the problem. Remember earlier in the video, this is the display that is not working and everything else is working, but it is this top left segment as well that is also not working, and that is not working on all of them, right? So that is why I believe we have a double failure. So if I test here, see? So that is the top left segment that is not working in any of them, and that works when I test here on the 7 segments. Of course, all the other segments also work. And it's the same with the display here that is never lit at all. So yes, I know it is the selector for that display, and I also know the line driver chip is not working. So I think I will try and change both of the things, even though my diode testing of that transistor didn't come up with anything. Just too bad. I don't think that transistor is defect. But now, since it's out anyway, just put another one in and just see. Yeah, it looks a little bit funny, but that's how it is with the pinouts. So I think we need to replace this 74LS47. So this is what I did, and I put in a new one and a socket. So now see if we are lucky. I already verified that this transistor had a positive effect. So now all my digits there on. I think I finally nailed it. So this is 2.345 megahertz. And I believe I got all the digits now. So it was a combination of a few things. I think the most, the thing that really sidetracked me, that was all the vias, or half of the vias, they're not connected anymore. So how the heck is that? So I had to stick through some pieces of metal and solder the vias on this display board. So this is definitely your lesson on the double-sided Pertinax PCBs, like the ones that this entire unit consists of. So if you have random connections or stuff that is not working in a unit like this, I would definitely attack the vias. I am quite happy the way this turned out. Look at that. And by the way, the frequency readout here is a few kilohertz wrong. So if I put this down to 1230, like that, you see? So that is not so good. But of course it is within what you would expect. Yeah. 200 hertz, it's reading too low. So I think I am done playing with this unit for tonight. The more I play with it, the more other funny VIA problems show up. Look at that one. See, there's now a new digit that is not connected. I thought I went through all of them, so probably I forgot one of them. So yeah, that is a nice CB tester from the good old days, where CB radio was definitely a funny thing. So thank you very much for watching, and have a great day. See you tomorrow. Bye bye.